Hi, colleagues. Hi again, who have joined us recently, and thank you for all who have stayed with us from the previous talk. It's the Quality Engineering Community Day 2023 that is conducted by the Global Testing and Pro-Quality communities. We are happy to see all of you with us, and our next speaker, Aliaksandr Valadzko, with the topic Improve Your Testing Quality with Measure Code Coverage. Let me remind you that the session is being recorded, and recording will be available in a week. Also, you are welcome to address your questions on the community page and in Discord. I guess we can start this topic.
Hello, everyone. So thank you for joining. Let me share my screen and start our today's presentation. Can you see my screen?
Yes, Alex, please go on.
Awesome. So yeah, today I would like to tell you some details about our approach, how we improved our testing quality and quality of our application using code coverage tool. So let me start. Yeah, my name is Aliaksandr Valadzko. A few words about me. I am a software testing team leader. I work for EPAM for the last 8 years, and at the moment I hold position of QA team lead. Our agenda for today is what and how do we test, our improvement idea and solution, benefits and use cases of it, and then we will have pretty short and straightforward demo and for sure Q&A session. So what and how do we test? Our system is 25 plus RESTful web services and several details that I need to drop here as well. This is pretty highly loaded microservice system, and it is in conditions of rapid development and distributed team. Web services are implemented and tested by different teams, different streams. Development can be out of sync and be on different phases. Test focus is component level testing of each web services that our team is responsible for. QA scope is overall quality of system under test, from requirement analysis to CI/CD pipelines setup and monitoring. And the main testing layer is isolated testing. And also it should be mentioned that from test environment, isolated layer is almost 80% of test at all. So let's take a look at following example. Let's assume we should test this like orange system under test. At this slide, we can see details of switching from integration to isolated approach. Application under test is a web service. It has two HTTP clients. It is consumer for 2 message buses, and it has cache layer, a database layer, some downstream services, and it produces SNS events. Our stack is AWS Cloud. So as a common and widely used approach, we test our services in isolation using test doubles rather than real dependencies. This is like this green arrow shows how we switch from integration, all of this complicated stuff, to isolated using Dockerized application with mocked downstream dependencies and infrastructure. And what bottlenecks isolated testing can handle? Dependencies can be broken. They can even not yet implemented, but you already need to somehow receive quality feedback regarding your application. They can be unstable. We have no full control of them. We can't trigger some exceptional corner cases on them. They can be owned by a separate team or even separate company. And quality feedback is shift to right. And isolated testing help you to shift your quality feedback to left as possible. It brings you testability. Testing can be executed locally. And it seriously increased the speed of your test execution and enlarge the testing coverage. Okay, so what was our idea? Let's recall our test ratio again. 80% of tests can be executed in isolation, but are they fully cover our application? Let's recall our development flow. So it is rapid development, we have poor planning, we have poor story writing, and team is distributed. So at least for our project, but I assume we are not only ones in this. For us, it means that we have poor requirements and we have user-facing logic that is not described in acceptance criteria or even can be not tracked in any ticket at all. So as a result, we can rely on something like traceability metrics, and because like user acceptance level is completely like broken and unstable and unreliable. But how can we create such mapping between test and our application? We made attempt to shift from user requirements level directly to application code level. We used a coverage agent on application side to map tests to application code directly. So code coverage is software metric used to measure how many lines of your code are executed during tests in our setup during our automated run. Let's take a look at our implementation of described approach. JaCoCo runs as Java agent. It is responsible for instrumenting the bytecode while running the tests. JaCoCo drills into each instruction and shows which lines are exercised during the test. To gather coverage data, JaCoCo uses instrumentation on the fly, receiving events directly from the JVM tool interface. Adding JaCoCo to your application is very simple. It's just one line changes. In slide, you can see that we just download the agent and add this line to our Docker file. And also configuring JaCoCo is very simple also. So as a result, our isolated setup after these changes contains this tiny JaCoCo agent that has capabilities to map automated test cases to code level. This is example of a JaCoCo report that you should be familiar with according to unit test practice, but here we shift from unit test to separate from external automated test. So JaCoCo reports help us visually analyze code coverage during test execution with help of diamonds and colors for branches. Red diamonds or red lines shows that code is not exercised during the test. Yellow diamond shows that code is partially covered, and green diamond means that all branches have been exercised during the test. Yeah. So let's move forward and discuss how JaCoCo is like drilled into our CI/CD model. Tests in our projects are included in definition of done for user story. That means that we use a following approach. This guarantees that only tested code is integrated to main branch, and main branch is always ready for release. So if to take closer at this scheme, we can see that we have like feature branches and main branch. And once feature branch is pushed to repository, the first step is build job that has following quality gates. We should have no code style violation, and we should have 100% of pass rate of unit test. And what are the artifacts that are generated on this step is Docker images of application and test for specified branch. And then we have isolated run. During the isolated run, application is started with JaCoCo agent. And after application isolated test finish, application is terminated and coverage data is collected. And quality gates in this step is we need to have 100% of pass rate for isolated test, and we need to met minimum code coverage value. And all of this like are prerequisites for pull requests. And only if you have enough test coverage, if test results are green, we allow to match code into main branch. That is very beneficial. So what are the like benefits and use cases that we can receive? JaCoCo solution is very lightweight. It adds additional 30 kilobytes to your Docker image. It is very fast. For all these additional CI/CD steps and quality gates, we in our setup we need something like 30 seconds. What are the benefits? Now we have clear mapping for test interaction to system under code, system under test code. We have quality gate that avoid untested code in main branch. We can do following. We can do regular exercise of analyzing the test coverage of our application and made some conclusions about untested features, untested models, and also we can like retrospectively analyze the defect and try to understand was our testing efficient or we just missed some part of code or some part of logic. What are additional use cases that JaCoCo can be used for? It's not only about isolated tests. You can use this additional JaCoCo agent in your integration environments as well, and even in production. Also, this is a pretty simple and pretty cheap way to quickly analyze test coverage of new project or project with lack of documentation or project with lack of test cases level and etc. But it is very important to understand and to remember that 100% code coverage doesn't necessarily reflect effective testing, because like poor code or defects can be covered by unit tests and it can be covered by bad and invalid automated tests as well. So like TLDR here is that is just another way, another angle of view for your application and for your testing. And now I would like to, before some very quick and very straightforward demo of how can we use JaCoCo in your applications. So I would like to start from this, let's assume that we receive following user story from customer. To implement, we need to add greeting endpoint to our web service, and acceptance criteria are following. It should has like /greet pass. It should has a required name query parameter, and we see the like description of what is expected response body and response status code. Okay, so let's assume our development team performs such implementation and just gave user story for testing. Let's start our application without JaCoCo analysis, just like clear application. Let's try to access it. Yep. So it looks like something works in our local machine. We have a RESTful web service. We have greeting endpoint that use name parameter to response. Okay, so let's assume now our automation team implemented test cases. Again, this is like very straightforward example, very simple. We just need to focus on setup of application rather than test cases level. So let's assume we analyze user story and implement following test case. We just send request, and we use data provider to verify that our application can handle strings, can handle numbers, can handle some kind of camel case, can handle specific symbols, and can handle empty line. And we expect that our application should return 200 status code and following pattern for response payload. Okay, so let's execute our tests. Five tests passed. We can see that we perform following call. We pass, for example, this parameter, and we received this response. Okay, and in regular setup, this will be the end of testing, because we cover everything that is described in user story. But sometimes it's not really this way, not complicated. Now let's try to add code coverage capabilities to our application. Let's terminate our application. Here you can see that I've already downloaded the agent to project. And now we will try to start our application with JaCoCo integration. Again, from configuration, this is pretty simple. You just need to specify additional environment variable for starting your application and pass location of Java agent for JaCoCo and like distribution, like destination of coverage report. Okay, so let's try to run our application now. We can see that it started. We can see that a required Java option was picked. And let's verify if our application is health. Yep. And now let's run our tests. Okay, again, 5 of 5 tests passed. And now let's try to create coverage report. We need to terminate our application. We can see that coverage file was created. And let's build the JaCoCo report. This is very easy. JaCoCo provides you a Gradle plugin to quickly add necessary tasks to your project. So let's try to build report. Okay. Report was built. And we can see that only 73% of our code was covered by our automation tests. Okay, let's try to see, do we met our minimum code coverage quality gate? Let's assume we have 95% like expected coverage. Let's verify it. Yeah, and JaCoCo says you that only 73% was met during your automation test. Okay, let's try to open the report and analyze what went wrong. We can see that controller and that our endpoint that was implemented during this user story, for some reasons that were not described in acceptance criteria, that are like hidden from test team, has this corner case. For some reason, we need to handle differently John name. We don't know why. It was just implemented, and we need to validate this as well. Let's return back to our application. We need to delete previous report. Now let's start our application again. Verifying health, everything is okay. And this test was additionally implemented. So we here verify that we can handle, for some reason, again, we don't know why, John name in some different way, by different response payload we expect here. Okay, so let's execute our expanded test suite now. Yeah, we can see now that we have 6 tests. Let's terminate our application. Let's build coverage report. And try to open it. Yeah. Now we have fully verified application from automated test side. And now we can run a minimum coverage violation rule to understand if we met our expected test coverage. Yeah, so now Gradle task is green. And actually, this is it for our demo. Let's summarize something that I told in this topic. So if your project has issues with user requirements level, if you want to quickly analyze test coverage of your project, if you want to do it on a regular basis and set quality gates for it, and in general, if you want to create mapping between automation tests and application code, you can use JaCoCo agent for JVM applications. But one more time, 100% of code coverage doesn't necessarily reflect effective testing. And actually, this is it. If you have any questions, please go ahead.
Thank you, Aliaksandr, for the very interesting topic. By the way, what I would say, alternative solutions besides JaCoCo, do you know, on the market?
There is EPAM Accelerator. that is called Drill4j, and it is actually based on JaCoCo, and it has a lot of additional stuff and a lot of additional features. But in our particular project, there were compatibility issues with integrating with Drill4j, and none of tested applications. We have 5 attempts of integration. All of these attempts failed. So we use clean JaCoCo because it is compatible with any JVM application because it interacts directly with bytecode.
Thank you, Aliaksandr. While we're expecting questions from the audience, let me ask you my questions. By the way, what is supported tech stack from application side for using JaCoCo?
Any Java application will be compatible out of the box.
Wow.
And this is very great and very useful item because once you create end-to-end setup for one of your application, you can reuse this approach of any other. You don't need to create some workarounds or some hints to make everything work because it doesn't actually matter. If it is Java application, JaCoCo will work by default.
Thank you. Another question: how many time is required to add JaCoCo capabilities to a particular application?
Thank you for your question. So, from our practice, POC was implemented probably for 3-5 days, but any additional application is added to our JaCoCo system and all these quality gates probably for half a day. It is very quickly. So,
right.
And majority of time is CI/CD, quality gates, configuration. From code level is several lines.
Yes, very impressive, by the way. Thank you, Aliaksandr. And another question: were there critical features found that was not found covered by the test based on your practice?
Yeah, this is very important question. So we found a lot of dead code in our application that was that we need to clean up. We found even several legacy features that are used by several clients, and we didn't test them at all. So it's another angle, and it can show you blank points of your automation. We definitely found them.
Great. Seems like there are no more questions anymore, and we can finish our discussion. Thank you, Aliaksandr, for the very interesting topic. Thank you, dear colleagues, for listening us. Actually, I would like to remind you that to join very interesting quiz that will start very soon, and that we will have a break till the 3 p.m. by Central Time. So we are waiting you on our channel at that time. Thank you, and bye-bye.
Thank you. Thanks for joining.
Thank you.